So because these two pumps are working independently, we could add these two fractions where 1/4 represents the amount that pump A can fill the reservoir in a day, and 1/3 is the fraction of the reservoir that can be filled by pump B, so that if they were working together, we would be able to know what fraction of the reservoir they could fill in one day. Now, when adding fractions, a nice thing to know is if you simply use alpha y equals and press enter, we could type in 1, and I always like to use the right arrow key to progress to the denominator. We'll press 4, we'll press right again, plus, and we'll do the same thing here, alpha y equals, we'll do our fraction 1 right 3. I don't need to go right any further. We'll press enter and we get 7/12. So let's always be clear once we do a calculation what we just found. So 7/12 is the fraction of the reservoir that can be filled in one day if they were working together. So if they're working together, so at the same time, but to fill the reservoir after D days to over 7/8 capacity, well, over 7/8 capacity we know for sure means greater than 7/8. So I could eliminate this option and this option here. And the difference between A and C is really that one of them has 12/7, one of them has 7/12. Well, we already figured out it's 7/12, but why is it being multiplied by D? Well, just think about if we had an easier fraction to work with. Let's say you had half. Now, what would you do with D, the number of days? So if I said, what's going to happen after 2 days? Well, you would intuitively multiply those and say, oh, after 2 days, once you multiply them, it's going to fill entirely one whole reservoir. So you multiply the number of days by the rate at which they're able to do so together. And again, we got our correct answer is C.